SciPAD page 208, looking at this idea of momentum. So momentum symbol P is equal to mass times velocity. Let's have a go at question number 1. A 7.3 kilogram shot put is thrown with an initial velocity v of 14. Calculate the shot put's momentum. And so simply mass times velocity, 7.3 times 14. And we type that into our calculator. We get 102.2. The units for mass is kg. The units for velocity is meters per second. The units for momentum is kg ms minus 1. Speed. Find the speed that a 4 kilogram shot put must be given if it's to have the same momentum as the shot put above. So P equals mv. If it's going to have 102.2 kilograms of momentum and it is a 4 kilogram shot put, then we simply go 102.2 divided by 4 would mean that it would have to have a velocity of 25. It's two significant figures, so it should really be 26 or 25.55 meters per second ms minus 1. Question number 2, a 920 kilogram rugby pack is moving down the field from right to left at a 3 meter per second speed and a rolling ball. Find the momentum of the rugby pack. That's the same as above, 920 times 3, which gives us 2,760 kilograms meters per second of momentum. 11.5 kilogram sack is dropped and hits the ground with 92 kilograms per meter second of momentum. Calculate the speed. So P equals mv. If we rearrange that, velocity is P divided by m. So 92 divided by 1.5, and we're talking about the moment just before it hits, so that there's no unbalanced force of gravity accelerating it. Means that it must have been traveling at about 61 meters per second. So it should just be 61, two significant figures. Question 3, a 1700 kilogram car is traveling east at 110 kilometers per hour. And so to turn that into meters per second, we divide by 3.6. Where does 3.6 come from? Well, we could times this by 1,000 because there's 1,000 meters in a kilometer, and in an hour there's 60 seconds times 60 seconds, so 3,600. So we could times by 1,000 and divide by 3,600, or I could simply divide by 3.6. So 110 divided by 3.6 means it's actually traveling at about 30.5 reoccurring meters per second, and then it is traveling east at 90 divided by 3.6, which gives us an answer of 25. So our car is traveling east, and it's overtaken going east. Convert the car 4.4 into meters per second. So that's 30.56 meters per second, and the 4x4 is doing 25 meters per second. Compare the momentum of the two cars, or the car and the truck. So the car is going to be 1700 times 30.56. So times 1700, and 1700 is two significant figures, and so I'm going to give my answer to two significant figures, which is 52000 kg meters ms minus 1 versus P equals the 4x4 has a significantly larger mass and not too significantly slower velocity, and we see that that means that the 4x4 has larger momentum. Cool. It did say compare, and so you could go 72 minus 52 and say that it's 20,000 more momentum or whatever, but that's fine. Question number 4, the concept of or use the concept of momentum to explain why heavy trucks are limited to 90 kilometers on the road while cars travel 100. Well, that is basically what we've just seen in question 3 above, isn't it? That in question 3, the 4x4 truck has more momentum, even though it's traveling at 20 kilometers slower. And so basically, the larger things are, the more momentum they have. If we look at what their answers say, they say heavy trucks have much more mass than cars, and so at the same speeds, heavy trucks will have much more momentum. Heavy trucks will require a much larger force to stop them than cars, and so, a 10k an hour difference isn't really going to make a significant difference.